So I want to first go over, before I go into what you could learn today, I want to explain what you won't learn today. This isn't going to be a code tutorial at all. Most of what we're going to talk about is going to be concepts, logic, just thoughts on actually starting to build a large-scale web app. At the very least, we'll show some code samples, just very bare minimal, just to give you the idea of what we're using, how we use it, why you would want to use it, along the lines of that. We're going to be discussing things that you're going to learn today, such as modularity. When you're dealing with a really large-scale web app, you want to ensure that it is as modular as possible, because you're going to have a lot of moving parts. You're going to have a lot of things, moving parts that actually might need separation. You don't want things to be too tightly coupled. So we're going to be talking about how to modularize specific components for use in a large-scale app. I'm going to give a little brief note on extendability, but I'm not going to get too deep into that. A good example of that is if you happen to have some sort of parents class and children classes that extend from that parent. We do that a lot in our app, especially when we use a lot of reusable components. The biggest topic of the talk, which will be toward the end, is mapping and brainstorming. A good way to kind of explain what that is our company, for example, we work with the design team, and the design team generally gives us wireframes and visual comps, and generally from there, we have to decide how are we going to break this out into an actual piece of code that we can use. So toward the end, we're going to look at an example of a comp that we've received and kind of do an impromptu explanation of how I would possibly pretty much decouple that into actual parts that I can turn into a marionette sub-application. I'll explain that term in a minute. You're also going to learn a little bit of CoffeeScript. We use it 99% of the time on our app. First started building it about 2 years ago, and we started with just JavaScript. But as we started to decouple things, have a lot of classes that inherit other classes, dealing with any sort of, well, prototypal inheritance in general, CoffeeScript was a lot easier. It was also nice going from 30 lines of code to 3. So that also helped. Just also preface, we're going to be showing both CoffeeScript code and JavaScript code in case people here are a bit uncomfortable with looking at CoffeeScript. So I think I first wanted to discuss modularity, the concept behind it. When you think about something that's modular, I kind of like the analogy of encapsulation. If you take into consideration a cardboard box, throw items into the cardboard box, it's staying confined within that particular area. It's not leaking out anywhere else. Everything that you put into that cardboard box is in that cardboard box. And I kind of like to use as an analogy to associate modularity and encapsulation containing bits of code for a larger purpose. Decoupling is another buzzword that I like to use when it comes to modularity. If you have a large-scale application with a lot of moving parts, you don't want to turn that into spaghetti code, and you end up seeing that a lot with much smaller apps where all the functionality, regardless of whether or not it's tied to DOM manipulation or something more so functional, it's all in one file. But we can go a step further in decoupling where we have functionality that's split up into multiple places that communicate with each other. That'll be another topic I'm going to be discussing, which is large-scale apps with event-driven communication, which is the next topic that I didn't go to. Another small topic we're not going to get too in-depth about, but it's something that we're going to bring up, which Alex will talk about, dependency injection. It's a bit of a balloon word or phrase, or word, phrase, something.
Umbrella term.
Umbrella term. There we go. It's an umbrella term that we hear a lot. I read a lot of confusion about what dependency injection is, so we're going to kind of give not a dumbed down version of dependency injection, but a low-level, bare-bones idea of dependency injection that we can actually get from Marionette modules, which it offers. Does anyone get this? It's the Octocat with a marionette. Isn't that crazy? That's my one cute image that I have. I know I'm funny, right? So I'm going to talk about the first topic of our larger topic, which is encapsulation and namespacing. A lot of the modules in our app are basically components of our larger app. So if you think about what kind of modules we would have in our application, a good idea of that is, let's say you go to a website that happens to have a splash screen that acts as the login and sign up area. The login and sign up area would constitute as something that you could potentially see as a component, something that you can turn into a module, and a module that you can actually namespace. So if we wanted to create some sort of module that contained all of the login functionality, we can namespace that, and we can encapsulate it in its own little box. As you separate things out, these small pieces of encapsulated code, they kind of start to become more pluggable, actually. One interesting problem that we had at our office when they decide, oh, we don't want this feature anymore, it's easy to remove it. I just need to comment out one line of code and the module's gone. That's awesome. So encapsulating things within specific namespaces as individual components, they become extremely pluggable and easily removed. This also makes it a lot more maintainable, too, because everything's separated into their own namespaces, their own directories, their own structure. Generally, with our sub-apps, everything has an identical directory structure. So we'll generally, which I'll display later, but the way that we've structured it is we have one main JavaScript file that communicates with our controller, and the controller communicates with our views, and everything's separated into different directories. But when we decide that we need to create new functionality, we have this sub-application template that we use, and it coincides with the idea of continuing to decouple our large-scale app. Oops. And I'll go a little bit more in depth with Marionette modules as an asterisk next to it, because I'm not going to show all the goodness of Marionette modules. I will discuss the one thing about Marionette modules, though, that I see a lot of confusion about. And if you compare it to something like Require.js or any sort of module loader, anything that has any sort of dependency injection built into it, Marionette modules is much more bare bones and low key, but it offers this really interesting, these two extra methods, start and stop. And I'm in the the Marionette Gitter channel a lot, and people, well, some people will say, well, why would I need to start and stop a module? Well, I can give you a few reasons why. So I will discuss one of those reasons, which we encompass in our app in a minute. I'm actually going to show a little bit of code. So now we have these concepts: modularity, encapsulation, dependency injection. One thing is when you're starting to build a large-scale app, where do you start? Because I can throw all these ideas at you, but then you're like, oh, well, how do I start this? If we look at a really regular, basic Marionette application, it's going to start with a few things. I'm going to show it in CoffeeScript first, and then I'm going to show the transpiled JS version directly after. If we go line by line, though, really quickly, the first thing that we're going to be doing is we're going to be creating a global, the global that we've dubbed my media. It's an iffy. It's nothing more than a closure that's self-executing, creates a namespace. The namespace is so we have access to window.mm, depending on the environment you are, which is web. You can't really use this in Node. This do keyword might look a little confusing, but once we look at the JavaScript equivalent, you'll notice, oh, okay, well, that's what that means. This is basically a short way of doing the iffy. So you'll see the translation of that afterwards. Inside of this closure that we have, this MM object, this is where we can start instantiating our Marionette-specific code. So the first thing that you do, obviously, is you're going to create a Marionette application. That's the fundamental thing that you need. Otherwise, you can't really use Marionette 100%. And we've saved this to a variable within this closure called app. So subsequently, with everything that we're doing, you're going to see this app dot variable getting used, and it's referring to the Marionette application. Some large apps, well, large apps especially, have layouts and regions. You can kind of bootstrap regions if you'd like before the app actually instantiates. You can use the add regions keyword. This is just an example of a couple of regions that we've instantiated. If you happen to have like a larger scale app, you might want to have a header region, a container region. Perhaps you have dialog boxes. That could be a dialog region. In our app, we have tons for individual components. And then the last few things is, I'll explain a little in further detail, but you have callbacks for before Marionette initializes and after Marionette initializes. We're still using 1.88, so we're actually using initialize before, but those of you that use 2.0 would use before start. We use this section to bootstrap all of our collections. This is where we start to, we instantiate our collections. Our collections are tied to endpoints, and the collections get populated from those endpoints. So down the line, we would probably add something like uploads, fetch, and then we'll have a callback, and that callback will do something. Alongside that, we instantiate some event handlers using regress. This is just what we happen to use when we instantiate our app. We'll talk more about event communication, but everything we do at the moment is a little bit more simplistic than it could be. And set handlers here actually will create these event namespaces that are actually tied to the collections that we're instantiating up here. So as soon as the app loads, we'll automatically have access to every single one of these events that we can request and get the bootstrapped collection data and reuse that through our app. Why is that good is because I don't have to keep reinstantiating all these collections. I have one global object that I can request at any moment, at any given time, and I have the data bootstrapped. And you have to start backbone history, so that's the last thing. JavaScript equivalent is actually not any different. You'll notice that it creates a normal iffy, executes toward the end, passes backbone as a dependency into this so we can use it. Nothing really looks different. I mean, if you're not familiar with CoffeeScript, well, actually, who here is familiar with CoffeeScript? Cool. It's lets you write stuff faster. I like it. It's great at build time. It's fun seeing everything compile, transpile. But yeah, it doesn't really look any different. The only differentiations is lack of parens and parentheses and whatnot. So I wanted to just quickly show an example of a Marionette module. We actually use these a lot in our code. It doesn't really look too much different from using require. The module method that you're noticing there would be equivalent to using, I think it's define. Is that what it is? I think it's define. I don't really use require. Pass in a namespace. And then you're also providing arguments as your dependencies, which Alex will go a little bit more in depth in. In JavaScript, almost looks identical. Nothing really too fancy, but we'll get a little bit more in depth with that. So on decoupling, there's a need for separation, especially when you're dealing with large apps and components that talk with each other. We have this one sub-application, actually. We call it the clipboard, and it has a lot of moving parts, and a lot of these parts end up communicating with a lot of other parts. And it's really difficult to see a really large sub-application and sift through all the code. So we have a lot of separation into various different files that serve various different purposes. So when you're decoupling code, you're separating. That's what decoupling more or less is. You're separating code. But you're also separating code that also has structure to it. They're not just rogue pieces of code in random files. They do serve a purpose. And as long as you have an understanding of how everything's separated and why everything's separated, there comes your structure. And modules are a great way to decouple your code. Having individual modules that can depend on each other and are dependencies of a larger entity, your large-scale web application. And that's more or less what we do in our app. It's just crazily modular, crazily event communicative, and we have a very strict structure on where everything's placed, to the point where regardless of who joins the company, the structure is there. It's very easy to see. It's very easy to get acquainted to it, and everything's namespaced, so everything becomes a little bit more visible. So I'm going to pass the mic over to Ian to talk about some notes on event-driven communication.
Oops. Did I go too far?
Down.
Oh, down.
There you go.
Yeah. So yeah, Mike talked a lot about how decoupling and how you want to modularize your code into all these different apps or sub-apps or marionette components. So obviously the next logical problem that comes from that is that you have to have these totally decoupled components be able to communicate with each other and sort of have a balance between the decoupledness and the communication between them. So here is a picture of our directory structure. So we're using Marionette and we have all these sub-apps. And just the two highlighted here, just an example of some of the apps that need to communicate with each other. So we have the Effects app and the Media View app. And the Effects app is kind of like our app for if we want to apply effects to your photos or show them in a grid on the home screen or anywhere throughout the app. We have an app for that. No pun intended. And so then we have the Media View app, which is the app that actually fetches the photos from our API, and so these two apps need to talk to each other. Or I keep saying apps; they're sub apps or components. Maybe that's a little bit of semantics right there. But so anyway, these sub apps need to communicate with one another because the Effects app can't do anything with your photos on our website if you haven't fetched them from the API yet, right? So these two apps definitely need to communicate, and the Effects app needs to say, hey, do we have the photos? Have you fetched them yet? And if so, let me have them. And so I'll get into how we deal with this problem of communication. Down. Yep. And that's by using the Marionette vent. We mostly use the vent, but when you do this app equals new backbone.marionette.application, which is, never mind, I was going to say CoffeeScript for a second. That's just regular vanilla JavaScript. You get the app vent, and you get app.recres, and you get app.commands, and these can be used for exactly what we need to do, which is communicate between our sub-apps while still keeping them decoupled enough so that we could just go ahead and delete a whole app like the clipboard when we decide that that's no longer an app that we want. So once you have access to those objects, the vent, the recres, and those are just from the backbone wrecker object, if I'm not mistaken, right? So those aren't Marionette specific, but Marionette does encapsulate them or give you easy access to them just by doing your app name dot one of those three objects. So anyway, once you have them, you can use them to communicate between your apps. So here's an example of how we use it. We say app.vent.on, recent photos, fetch, success, then CoffeeScript for function, callback function, do something. So that's basically registering an event listener for that namespaced event. And then later on in the app, we are going to say app.vent.trigger, recent photos, fetch success. And wherever else in the whole app that first piece of code was, it's going to hear that and it's going to say, great, we got the photos. Let's put an effect on it. So maybe jump back to my example a little too quick there, but this would be in like the effects app, and this would be in the media view app where we're actually fetching the photos, right? So, and then I think I got the JavaScript version of that. Yeah, so basically this, yeah, just the same thing, it's just JavaScript now. And then I threw in like, this is what you might do with the photos once you fetch them. You might want to do this dot show recent photos. This would be referring to the effects app, which is the app which this piece of code resides in. Yeah, and that's actually all I got. That's communication. So Alex is going to talk to you a little bit about another problem that comes up when you have all this decoupled code, and it's dependency injection.
Hey guys. So one of the great things about Marionette modules is how easy dependency injection can be. And I guess everyone here likes reusable code and flexible code. So at least I do. And one of the great things about dependency injection, so you guys know it's a great design pattern that allows us to provide dependencies to several components. Since we have several sub-apps within our main app, we want to keep everything to be as flexible and reusable as possible. We want to plug things in and out. And so dependency injection allows us to be flexible, be reusable, and also we're actually in the midst of starting to write unit tests for everything.
Isn't that sad we don't? Yeah.
So testability is a thing that could be beneficial. Well, dependency injection allows testability to be even better because you can just inject mock dependencies into a module and see if it's working properly. So that's a great thing. And I kind of want to show you like a brief code snippet on how dependency injection is in a Marionette module. Basically, it's just the same Marionette module that we saw earlier. This is our notifications app, and as you can see over here, jQuery and underscore are known dependencies of Backbone, and Backbone itself is a known dependency of Marionette, and so those are three things obviously that we're going to provide as dependencies. We're also providing the main app, and at first it was kind of confusing, like why am I providing the app to its module? And it makes sense that you want to be able to access all these global events, all those events and methods that are namespaced and encapsulated within the main app. And providing that app and providing Backbone and Marionette just allows you to have access to all the tools that you need to have a module communicate to anything else. And this is pretty much like the bare bones essentials of how it would be. Let's say I decided to create a Backbone object for some reason, BB will be it. And this is kind of the equivalent in JavaScript. One thing that I noted in CoffeeScript, when I first started learning Marionette, I kind of like, so I was learning Marionette, Backbone, and CoffeeScript at the same time. So it was kind of like, whoa, what's going on? Because I was just strictly Angular, just vanilla JavaScript, no CoffeeScript whatsoever. CoffeeScript allowed me to learn a lot of all these like essential components to building a Marionette app, and if I see this code, kind of like I knew what was going on, like easier than if I was just looking at this. Especially if it's like a larger function, where I can see where every single dependency is going through in the app, so I know where everything is organized. And we're not gonna go too much into detail when it comes to dependency injection. I assume a lot of you guys know and have your own practices when it comes to that. I just want to give it back to Michael, so he's going to offer some final thoughts. And are we going to show anything from the app?
Maybe.
Maybe?
I'll see. Yeah.
Just get back to you now.
So this is the part of the presentation that I hope goes well. I'm actually going to... I hope it goes well. So the one thing I wanted to talk about is how do you go from A to Z when you have an idea, you have a visual comp, you have something, and then you're sitting at your desk at work or at home, depending on what you do for a living, and you have no idea how you might be able to take this idea or take this visual and actually destructure it into something that you can actually start to code. So that's turning an idea into an app. How do you kind of do that? Visual comps help. They really do. If you don't have them, it makes the process much more difficult. I've been in a lot of situations where I spend more time coming with ideas than coding. And I'll do that for like a day, and then I gave up on the project because I tried to come up with a name. So visual comps help. Give me the idea, I'll build it. I don't need to be creative. Knowing when to split things apart. If you do get a comp, and you have zero direction on how it functions, that's not good, because all of a sudden you build something and then, oh, this is supposed to expand here. Well, I didn't build it that way. So having a clear, concise idea of when to destructure things, when to decouple things, it's a good idea to preemptively have before you actually get into doing it. That could be anywhere from actually having comps or just whiteboarding it. Get a giant piece of paper and draw out a wireframe, cut things out, tell yourself what this is actually going to be and how it's going to move and interact with something else. Multitask your thoughts, and I do that a lot because you might be starting to think about one particular subject and not thinking about the other. So it's good to visualize everything as a whole, about how one thing may interact with another or inadvertently interact with another. So now I'm going to start to improvise. Hardcore. I did not write any notes for this. Destructuring a comp. So I'm actually going to show a comp that we've received from our design team. It might be a little bit difficult to see, but we're going to actually focus on the vertically rectangular blob that's on the right.
Full screen.
Just zoom in and
Can that work? Can I do
just
that?
Control-Shift-F.
I don't know how to do that. Do it.
I mean, you can zoom in. Yeah, it won't be any bigger. Just zoom into the screen.
I don't know how
Oh,
to.
Command plus. Yeah.
Command plus.
Oh,
No, use the
well,
mouse.
that I know how to do. Well, okay.
No, use the internet.
I know, crazy internet, right? So, I received this. That doesn't give me anything. Oh, shit. Ignore that.
Oh no.
Then that doesn't. Oh, no. Imagining that I received this from the design team, you may or may not get this depending on where you work. But more or less, they'll send me something like this. Great, I know how wide it is, I know how tall it is, I could do that myself, I really don't need that. They don't even give me hex, well now they started to give me hex code, they didn't have that before. I know, I had to force them to do that.
Design team.
But if you actually take a look at something like this, right off the bat, you might not necessarily understand what you should be doing. It's not until you actually get an idea of the actual user interactions, because that honestly becomes the big key of how you're going to structure your app. Because what I didn't know until I actually looked at the animation was that these are actually two separate pieces. The top portion of the bar with the X and the uploading 3 photos, and the very faint line there separating the individual items. Apparently those are supposed to be completely separate because as the items get knocked off the queue, the div shrinks, and then as soon as the div shrinks, it ends up being 0 pixels tall, and you end up with just that top bar, and the top bar animates out. How was I supposed to know that? I was like, okay. So back on destructuring, how do you destructure that? Well, you have to take user interaction into consideration. What are people going to click? What's going to happen when they click? What effect might happen when they click? Is something going to disappear after X amount of seconds? Do I need any sort of timeout? Do I need any sort of interval applied to this? You have to have all these ideas on how it's going to interact, because it's good to have a good idea up front. You're never going to know 100%. That's what refactoring's for. But it's good to have an idea of how the end user is going to interact, not how you're going to interact necessarily. Animation and state is a big one. Clearly like the fact that the top part of that bar animates. I didn't find that out till later. That was wonderful. Understanding animation and state, where are things supposed to be at what point in time? Is everything going to be completely static, or are things going to be disassociated with other things? Does one disassociated thing have to communicate with the other one? It's a necessity to understand that. Separation of concerns. Does one thing have more capability than the other? Is one part of this sub-application just completely stale and another part of it does a lot more work than the other? Having an idea of how everything is completely separated, what communicates with what won't communicate with what, separating out your concerns on how it should function and actually be presented to the end user. Mapping. Where and how is it contained? How do you take this one interesting piece and how do you turn it into some sort of component for your app to be used? We used a buzzword earlier. We said sub-applications because if we take into consideration that our app is an app, then small individual components within that are our sub-applications. So we go between the three different words, modules, components, or sub-apps. Modules doesn't make any sense anymore because we could have a group of modules that does one thing. So we'll generally either consider it to be a sub-application or a component of sorts. Then we start to kind of wonder how we turn something like that into marionette views. I'm sure everyone's familiar with the view hierarchy. You have your layouts, your composite views, your collection views, your item views. How do you look at a picture or an idea and decide, well, this thing needs to be a layout. This layout needs to contain regions. Those regions need to instantiate composite views. Those composite views need to instantiate item views. You're not going to know that right off the bat. So if you start to map things out and get an idea of how things are going to have a certain view hierarchy, it gives you a better idea on how to structure something. Splitting things into regions is something that I notice a lot of people, not a lot of people, but some people have trouble with. What's the necessity of a region? If you think about a layout view and put it into comparison with a blog, for example, the blog itself could be considered your application. The header of your blog could be a layout view in the event that you want to split that up into different parts. If it's just going to be a logo, then it can just be an item view because it's serving no other purpose than being a view. If you happen to have a sidebar, for example, you have a part of that sidebar with recent posts, external links, tags. The three of those things can be regions. Those three regions can instantiate either item views within them. They can instantiate composite views within them if you happen to have something that iterates, like links. Starting to separate the concerns is where that kind of leads back to knowing when to use composite views versus collection views. I overheard you mentioning about composite views take templates, collection views don't. That's true. There's scenarios where you might not need a template. In the later version of Marionette 2.0, you can pass a false for template if you don't want to use one. But if you're not going to use a template, you might as well just use a collection view. I don't think there's any further differentiation between the two aside from the template. Kind of touched down on that. So here's a really ghetto annotation I did. This is another part of a comp that we received. It basically showed the extended view of this sub-application. So as you take a look at this, you kind of try to destructure it in your mind. Which part of this is the layout? Which part of this is the composite view? This is actually one layout. The entire teal part of this is the layout. The uploading 15 items bar is a composite view. And the second part of this is a composite view. And both of these are being instantiated in two separate layouts. There's the upload header layout, and then there's the upload body layout. Since both of these, So the top part actually could just be an item view. I think it actually is because we're not iterating over anything. We're just showing a static view there. And that view has some ghetto data binding that actually keeps track of the size of the collection and updates with how many items are in the queue. The second half is a composite view with item views within it. Each of these item views are the individual items. And with some Sass magic, you end up with a really pretty interface. But if you look at a comp like this, it's good to start to have a preemptive idea of how you're going to start separating these and getting an idea of how things are supposed to interact. So the reason why those two parts are decoupled is because of the fact that once the bottom part collapses, the top part is going to go in a different direction. So it makes sense that you're going to decouple those two things. So thinking in the sense of that gives you a better idea of how or why you're going to do something a certain way and how you're going to break it up. Luckily with Marionette, it's really easy to change things. You can easily change a collection view to a composite view. You can easily change an item view to something else, depending on how much logic you've tied into it. And here's the animated version of how it actually turned out. So the user would drop in images. It would have a progress bar. As soon as the item has uploaded, it sends it goes into processing mode, and then we have a server that's tied to RabbitMQ that sends notifications our way, and based on the notification that's tied to a particular model for each of the line items, determines whether or not it's finished processing. Once it's finished processing, we catch an event that says that. The event then tells the view, remove that from the collection. Since Marionette automatically updates the collection based on add and remove events from the collection, it will subsequently remove it. And there's logic tied in saying that if the collection length is 0, collapse that top part. And that was my winging it just now. Thank you.